In the world of mathematics, you've got your everyday numbers, right? Like 2 or 1/2. They're simple, familiar. But then there are the others. These strange, mysterious constants that just pop up out of nowhere, holding all kinds of secrets about how the universe is put together. Today, we are opening up the case file on one of these numbers, a constant that's just full of twists and turns. Okay, so let's meet our main character, the MRB constant. We'll just call it S. Now, look at how this thing is defined. It's kind of weird. It's an infinite sum, which means the terms just keep going and going forever. And see that little -1 to the power of n? That makes it an alternating series. You add a term, then subtract the next, then add, then subtract. It's this incredibly delicate mathematical dance. So what does this infinite dance actually add up to? Well, it's this number right here, about 0.1878. And we can calculate its value to a ridiculous number of decimal places. So we know what it is. But here's the thing. Knowing its value isn't at all the same as understanding its true identity. And that right there is where the real mystery begins. This brings us to the million-dollar question. What kind of number is S really? Is it a rational number, meaning you can write it as a simple fraction, like 1/5? Or is it something way more profound, like pi, an irrational, maybe even a transcendental number that just goes on forever without ever repeating a pattern? This is the central puzzle that has had mathematicians stumped. So, to try and crack this case, researchers started down what seemed like a super logical path. They have these incredibly powerful tools for analyzing these kinds of problems, and the first step looked really promising. It was time to take this messy, clunky, infinite sum and find a whole new way of looking at it. The strategy itself was pretty clever. Imagine you're trying to measure a really jagged staircase. It's kind of hard, right? All those separate steps. But what if you could just replace it with a smooth, continuous ramp? That's basically the idea here. They used a powerful mathematical tool called contour integration to turn that jumpy step-by-step sum into a single smooth problem. The hope was that this new, smoother perspective would finally reveal the constant's true nature. But this is where our story takes a really dramatic turn. That path that seemed so clear, so direct, it led them somewhere completely unexpected. The most logical technique, the one that absolutely should have worked, produced a result that just left everyone scratching their heads. The case went cold. So, the big moment. Did it work? Did this elegant transformation from a clunky sum to a smooth integral finally give them the answer they were looking for? Did it expose the secret identity of S? No, not even close. What they got was a complete shock. They were expecting to find our target, a simple, real number. Instead, the calculation spit out something totally different, a complex number. You see that little I there? That's the imaginary unit. This wasn't just wrong. It was like they were looking for an address in New York and ended up in a different dimension altogether. But this new, weird, complex number wasn't just some random error. Researchers quickly realized it was like a mathematical shadow of the original. They named it C for continuous analog. It turns out that the most direct or naive way of using their integration method doesn't lead you to S at all. It leads you to its strange, complex cousin, C. Okay, so the investigation wasn't over. This initial failure actually pointed them in a brand new direction. They knew the right answer had to be in there somewhere. They just needed to figure out a way to filter out all the junk from the calculation and isolate the right one. They needed a key to unlock this puzzle. And they found it. The hero of our story is a technique called Abel regularization. You can think of it as a way to gently guide a wild, chaotic calculation and kind of force it to behave. It's a special method for taming unruly mathematics, and it was the perfect tool for the job. So how does this magic work? The process is actually pretty elegant. You start with that same flawed calculation, the one that gives you the wrong, complex answer. Then you add a temporary control knob. It's a tiny mathematical factor that makes the whole thing stable. And with this little regulator in place, boom, the calculation suddenly points to the correct number, to S. Finally, you just gently turn that knob back down to 0, remove it, and the correct, stable answer is all that's left. By applying this Abel regularization method, the problem was solved. That phantom imaginary component, the part with the I that should never have been there in the first place, it just vanished. Poof. What was left behind was the pure, real value of the MRB constant, S. The method actually worked. So, problem solved, case closed, right? Well, not quite. We now have a solid way to calculate S and to prove that our calculation is the right one. But this brings us right back to where we started, to the original mystery. We know its value, but we still don't know what kind of number it is. And this slide, this really puts it all into perspective. I mean, we've known for centuries that numbers like pi and e are transcendental, but just look at the MRB constant. Just like another famous mystery, the Euler-Mascheroni constant, its fundamental nature is still officially classified as unknown. It's a member of a very, very exclusive club of mathematical unknowns. So what's the gut feeling among the experts? Well, based on its structure and how it behaves, most researchers are pretty sure the MRB constant is transcendental. But, and this is the huge but, that is still just a very well-educated guess. As of today, nobody has been able to actually prove it. The case remains wide open. This story of the MRB constant is such a great reminder that even in a field as exact as mathematics, there are still these deep, fascinating mysteries waiting to be solved. And it really makes you wonder, doesn't it? What other secrets, what other beautiful and complex stories are hidden in the numbers all around us, just waiting for someone to find the right key?